Hello, my name is Lonnie Pagel Jr. and I am going to record this in hopes of helping some of you out there who may be interested in going into computer programming. Now, it took me a long time to learn this, but there are some mathematics you may not be aware of. One, there is such a thing as the hexadecimal number system. Now, the ordinary progression of the base 10 that you are familiar with, when you get 10, you put a 0 on one side in the ones column, and the place value next to it is the tens column, which is why we say 1 and then the 0 next to it, that is 10. Now, we have also a base 16 number system. In that number system, the 0 and then the 1 right next to it looks like 10, but in fact it is 16. Case in point. Now we have here 1. What we will do is we will find out exactly in this segment, which I am doing to help anyone who wants to learn. Now, I want you to pay close attention to what I'm about to say because it is of necessity that you know this. Anyway, here's the way it goes. Now, there is, as you know, numbers 1 through 9. But when you get to 10, in the hex number system, it goes to A. The letters range from A to F. Now, we break these down into 4 binary digits at a time. And we can divert, or convert rather. Yes, conversion would be a better example. We would then convert an A to binary 10. Now, in order to do this, one must remember that just like any other number system, there's a ones column, a tens column. In the number system you may be aware of, there's that, as you may have learned a long time ago in grade school. But now, the base 16 number system goes like this. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. F is equivalent to 15. E is 14. D is 13. C is 12. Now, you get the idea? B is 11. And A is 10. And in order to reach that number 16, the way I was taught to do it was you put on the paper 16 to the 0 power, your numeric coefficient exponents, as they call it. All right. Exponent number 1 is 10 to the 0 power ordinarily. But since we're using hex, it'll be 16 to the 0 power, which whatever it is in what would ordinarily be the ones column, if you have a letter there, for example, F, if that letter F is sitting there in that column, then the 16 column, 16 to the first power, which is whatever the number is, for example, if you have the number 9 right next to it. So it'd be F9. All right. Now, usually you're going to see these in number strings. So, a good example of that is you must remember that as you go on in the 16s, base 16, all right, then you got 16 to the second, 16 to the third power, 16 to the fourth. You get the idea by now? If not, I will demonstrate. But before I do that, I must write it down on paper. Now, what we do here is we take and we write down just some random numbers, or what would seem to be random numbers. Okay? Now, this kind of thing is used in computer programming. All right? Now, the base 16 will convert directly into binary. All right? I will give you a very good example. 4 bits is called 4 binary digits. Okay? So, we don't count the zeros. So, an F is 4 ones. Got that? All right. Now, in order to understand what's going on here with binary, first we have to understand binary. So, it also uses a place value system. You go 1, 2, 4, 8. And as you go further, 16, 32, 64, 128, 128, 256, 512, 1024, and you just keep going. You'll end up with 16 to the third, 4096, as you continue to double it as you go along. But this right here, this ought to help you understand binary just as soon as I show you this paper. Okay? Now, I want you to pay very, very close attention to what I'm about to show you, because there's not too many people who will show you this for free, as I am about to. Now, observe. I'm going to write down zeros and ones, okay? And then I'm going to convert that to decimal. Okay. Now, do you see this right here? All right. Now, you will notice that on one end, which